Hello, hello. Turn this down. Hello. Okay. See how all this cool stuff works. BRB. Oh, okay. Oh shoot, let me fix this. There we go. Looking all nice and pretty. See my ashy ass elbows. Let me do front camera on this one. Osmo. Oh. Is this not working? Just setting this up real quick. I'll probably delete this. Don't worry about it. Did it work? Okay, hang on. How's it? Find my ugly mug. Ta-da! All right, cool, sweet. Let's cover this up. All right. Got all that set up. Let's see, get the logo straight. Cool. Unfortunately, my live chat's not working. Let me see if I could pull that up on YouTube itself. Let me see if I could pull that up. I think I can. Hold on, let me double check. I'm just setting up some stuff up and then we'll get to what we're going to be doing. Chat. Guess it's working on the website, so I'll just go use YouTube chat then. Interesting. All right, anyways. Okay, all right. Get a view of what I'm doing here. Okay. So what we got going on today is this. I'm gonna finish this up. So we're gonna, by the end of this, I want to do at least one roast on the new motor. This is a V1. This has a V2 motor on it, and this is all a V1 setup, because this is what it would look like if it was a V2 board. So, or cyber roaster, or I don't know what they're calling it. You know, hold on. Echoing. Anyways, okay, so what we're gonna do is gonna finish this up. So not the last thing of it. I got it working. The motor is running as it should on Artisan. So what we're gonna do next is install the fan. Now you need a fan to be blowing on this because this gets extremely hot. Not crazy hot. I got it in open air to get up to like 60 C. So what's that in American? Like 130 Fahrenheit, 60 C to 140 degrees Fahrenheit. So that's not too hot for these motors. These motors usually can go up to like 80 C, but if you get that high with this motor, it's gonna shut off. So once that shuts off, your roast is done. This is why they added a fan to the V2 or the Cyber Roaster Delta, whatever you want to call it. They added that so it wouldn't overheat and mess up your whole roast. And it's pretty much the only reason why they added it in, to cool it off. They needed a small enough motor to use. These have a ton of torque in it. The only issue is it generates a lot of heat and by itself. Then you have to add in certain factors like consideration of how the distance is between this motor and the back of the drum. So that gets like what, 220 C at when it's really high, or up 200 C, 200 degrees Celsius. Should stop saying C. 200 degrees Celsius. Then you have a motor mount attached to it, and that's going to only just transfer heat to this, so that's going to cause it to even the temperature to go up higher. So this definitely needs some cooling. They actually use not a 40 millimeter fan that usually comes with others. They actually use like a 30 millimeter fan. Custom fit, so they usually, when I say custom fit, they just cut this end right through here, and they'll just shove it in the bottom, and they tilt it up a little bit so we can cool off the motor. We're gonna try to get away to see with the smaller motor, and I think I'm gonna elevate it a little bit, but this will be pretty easy. I just got to add the holes to this, and then it should be good to go. So let's give that a shot, and then we'll do a roast with it. All right. So you just need one of these motor mounts, and get one of these motor mounts, add one of those motors, which is the JGY 2838, and you put it on like that, and then you just put it on right here. And you have to get like a little special coupling between that you can make yourself using one of these couplings like this. And then you would add like a 3 millimeter screw that goes in here. So you'll get like 2 of these little 3 millimeter screws, M3 screws. Put it here, one on this side, one on the other side. And then those parts will sink right into the little slot that's already drilled in, or that's already made into the drum. And that will kind of it does a lot better than just having this like little shaft rotate it. It kind of helps it. So you'd use one of these, put those on there, and then you would use, I use just one of these to hold it in place, little M3 nut. That actually fits perfectly into the slot too, so it actually holds it. You can have it hold it in place. Hold that in place, and this nut will fit right into the slot. So it works out pretty nice. A nice little setup. And that's how you're gonna have, couple it against the drum. And I did a video about that before a few weeks ago. So now I just want to finish this up. So I'm gonna start drilling these holes. So I'm gonna pull out the power supply. Drill some holes in here, so I'll just use this as like a little this is plastic, so it'll go right through. I'm going to use one of these little M3 nuts to hold it in place too. You need like a 13 millimeter. So I'm just going to tighten this up just to hold it in place. I don't need it super tight. I just need to hold it in place while I drill the other holes, okay? So, go ahead and drill another hole. Just do 4. You don't have to do all of them. Now you can have a few options here. You need to give it space in between, like a little bit of air gap so it could get the air through. Or you could, you know, put some holes in between. I'll put a few holes in. You just go down the line and put some more holes in, but I'm mostly just gonna raise it up a little bit. How am I gonna do that? I'm just gonna use these little nuts. Put one of these in. Tighten them down. And I just need a little bit of a gap. Just like that. Just a little bit of a gap. Let's see, I think I'm using a 16 millimeter. Yeah, looks like to be a 16 millimeter length M3. So I'm just going to give it a little bit of height, just so the air can get you know, air pulls from the bottom, and a little bit from the power supply compartment. So this is the power supply. I'm hoping that it doesn't hit it. If not, I'm gonna have to use a bit smaller nuts, or a bit smaller screws. Oh. So here's, would I have the original motor? If I show you the original motor, you can see there's kind of quite a bit of difference. Actually, the small motor is not that bad considering the size of it. It just wasn't really built for it. You could tell because there's a plastic, basically well, maybe like some kind of bakelite or plastic gear in there. Not gear, was it gear? Well, something basically is plastic in there. And it has a tendency to either break or melt. The whole thing itself just kind of dies pretty quickly. But they're cheap as chips to purchase, so if you ever do break one, you can always just buy one. It just takes 10 days to come over the boat. Cool. I'll see if that's a big enough gap. Looks like it. It goes a little off on the holes. Looks really off on the holes. Jeez. Oh, it's because I bent it a little bit. Yeah, kind of messed up on the holes on this one, so I just gotta move the holes down a little bit. A little big. Just a sloppy hole job. Actually, you could get away with that. That works. Probably because I use a cheap fan. So I'm just going to put a washer in it now. Because the M nuts are just like sinking into here, and there's like just a cheap plastic in there, just kind of just pulled it in. So I'll just go ahead and do this. Put a little washer there, and then I'll put the little M3 in there. And then just to save me a headache, I'm just going to angle it like they do in the V2. Have a little bit of an angle on it. Well, works out. I'll put one screw in just to kind of hold this one side down. I guess I gotta just put a hole in. Oh, get a longer one. I'm gonna put a little nut right there. Hopefully it won't interfere with the power supply. Well, if it does, then I'll just pull it off. Okay. If I have little tweezers to hold it. The original thing I was gonna do, but I never had time to do it, was just print out a new one and just add a fan holder in there. I gotta remember that everyone doesn't have a 3D printer accessible to them that could print ABS, because you'd probably need to put this mount in ABS. I'm just trying to manhandle. You know what? I'll just tighten it this way. Good. So I got a little nut down there. It's holding on to it, and now there it goes. All right, so let's see if the power supply fits in just fine. It does get in the way. Oh, if that's the case, I'll just take it out. It hits the really tall part of the power supply. I'm just gonna leave it floating like that. So it doesn't hit it. And I'm just gonna put it back in. There it goes. That should work out. I just need to make sure that there's a little bit of a gap so the air can come in. All right, let's go put the wires back in. All right, and it should go in like that. All right, I'm gonna put this back together. So we got this connected, that's connected to that fan. And if you're ever wondering, the power supplies, they're really cheap. Where's one? So usually the model number kind of gives you information about what it is. So this is a Hanyi HYS30 24AZ. So 24 is usually the 24 volt, and then 30 is more than likely the watts. So at max, you could probably pull maybe like 1.5 amps off of this. Something crazy like that. That's what I'm assuming. But yeah, HYS30. But anyways, I think you could find models with the same kind of dimensions that does like higher wattage output, but or give more amps. So I was thinking of grabbing one of the because it almost has the same dimensions as the Kaleido ones, their power supplies. So I was thinking about grabbing a Kaleido power supply and see if I could just swap that in there. We'll see. I purchased one. because I can't find any like in-depth information about that model in terms of how much watts it has. So my best guess is that the 30 means 30 watts, but hopefully it doesn't because it's really low. All right, let's put this back in. Oh, let me plug this back in. This is the exhaust fan. I'll pull it out, grab the heat sink and just pull. Oh, this is even out of the slot. So let me move this a bit. There it goes. Let's put those wires back in. Just make sure the wires fit in that little gap that's right in here. Otherwise, it doesn't press up against the side of the back panel as well. That looks good. That looks good. I want to make sure that's going sweeping underneath and out of this area, general area. Oh, and then this fan, this exhaust fan. Move this out here. Plug that back in. Don't pull too hard because you will take these off and you'll have to resolder it. So if you don't have a soldering iron, consider getting one if you're going to be tinkering on this, but just don't pull this. They're easy to solder back if you have a soldering iron, but because they already come with shitty solders as it is, but that just means they come out pretty easily too. So just be careful. Actually, I'd probably be recommending just kind of maybe put a little flux and then heating up that solder joint just a little bit better, because I've noticed that they pop out really easily if you're not very careful. All right, so if I'm pulling out this board, I'm just going to grab the heat sink and I'm just going to pull. The drum motor used to go in the middle one, but I'm routing it straight into the power supply. But I am gonna put the exhaust motor back on. Let me double check if that's the exhaust motor or exhaust one. Skywalker. And if you ever have any diagrams, I usually put them on Skywalker. Which I need to really, really organize. Hardware, main board. Okay, so just remember, let me put this on. Oh, that's me, sorry. That's the wrong one. I'll put display here. Display 1. All right, so just remember, you got main power supply, and you have your drum, mine polarity, and then your exhaust fans here, and then the rest is fan, cooling bean fan, or bean cooling fan, bean cooling fan, then NTC probe. So if you ever forget, one day I'll actually label them all, but for now, we'll put the board back in. Good. All right. Make sure those wires go in there. I'm gonna have it back onto the back panel. So what, you probably can't see, but I'm just sweeping the wires to make sure they go on a certain side. Do I have one? I don't. I usually have a spare coffin somewhere, but it's all right. Electronics coffin. But just be mindful of the wiring. Make sure you're not pressing up against the, and the thing's getting squished and getting pressed up too hard against the back panel. Make sure everything's coming out of like an appropriate hole. Also, feel free to drill in a hole if you want to, you know, route a wire differently. I got a new toy. I got this thing from Costco. It sounds all fancy. We'll see. I've been using it. It's kind of slow. I kind of like my Vessel one a lot better, but I'm going to try this one out for a few days. See if I like it. All right, so line up the holes. Best way to line them up is to line up the USB ports at the bottom. Make sure those line up to the corresponding holes, just like that. And then what I'll do is just hold it in like here, and then I'll put the screw in. Mind you that these are threaded, so always remember to use the threaded ones on these. Just make note that they do, this is one of the few screws that changed from the M4. This is just the regular threaded one. Good. Hand tighten them, especially when it comes to threads. Hand tighten them at the end. Let's see if I could close this. If not, I'm gonna have to reroute it. I think I'm gonna have to reroute it. I'm gonna figure out what the best avenue to reroute it. Well, I won't put the back plug back on. I'm just gonna reroute it through there. So these will stay in here. And the only ones you really have to reroute are the ones that go into the Arduino Nano. No, I have to yeah, I've got to reroute it. I'll probably use one of these holes. Yeah, that should work. There's only shit. Did I use D7? Guess I'm going to find out. So I just remember that D5 is yellow and D6 is blue. This is for me. D5 yellow. D5 yellow, D6 blue. Let me put that in chat. D5 yellow. D6 blue. Now the thing is, I gotta figure out where I put white. Okay. So we'll back this into here. Make sure we're not crimping any wires. Make sure nothing's obstructing the fan. Good. Okay. We'll put each wire through here. This is temporary. I'm gonna make it all nice later. I just want to get a roast in before I go to sleep. So there's 3 wires. I think yellow is, I know blue is the PWM. I think white is direction. And then I think yellow is hall sensor. Okay, step 1. I gotta bring it out the other hole. There you go, just like that. And the other wires are inside, so they stay in there. I don't want to, like, there you go, ruin the wire. So there goes there. That goes in there. Make sure that lines up with the outlet. And then we're gonna screw this back on. Make sure this fits in. Perfect. I won't put all the screws in. I'll put just the 4 corner ones. So I use Wagos to put together the inline Wagos to put the drum motor and the cooling drum fan motor together as well. Yeah, we'll keep that off for now. Should be fine like this. This is my testing unit anyways, so we'll see how it goes. All right, now let's see if I can remember. D5 is yellow. I want to say D4 is white. We'll see. I'll plug it in and we'll find out. You know what? D7 was kind of tight, so I'm going to put it in D7. It might be D7. I might have skipped D4. Oh yeah, it looks like there's a little bit of wire in there. So I think the white one went to D7. I'll have to check my code later, too. But we'll see, because this was already working. Okay, this will go right into here. I'll have to make something nice to where, like, goes onto there or something, right? But we'll deal with that later. All right, let's see if this works. Plugs in. Oh. Cool. All right. Fan turn on automatically. I gotta figure out that one. See if I could turn off the air. That works. I don't know why the fan turns on automatically. It shouldn't do that. If I unplug it and see what happens. Okay. It's being weird. Right, so I gotta set things up for the slider. So I want the drum on, cool off, cool on. T2 is not working. It was working before. I'm gonna try another plug. It's reading temperature fine. Temperature's being read fine. Air just wants to turn on. Wasn't doing this before. Wait, did I put in the right one? I did. Put the exhaust fan on. But now it's constantly on. Let's see. We'll know if it works for sure if I plug this in. So right now I'm going to plug in the controller. Still got one, huh? Oh, because I don't have the jump. That's why I was like, I wonder why E3 is going off. But this is still going on. Preheat's on, right? Oh no, because the jump's off. I'll turn that off. Plug this back in. And I need to unplug it. Okay. Damn. I gotta check the code. If I take this off, still spin? If I plug it. It does turn back on. That should stay off. Well, I gotta check my connections. Oh. This is why I didn't want to put all the screws on. But I'm up and unplug this. Make sure to feed some wire in there. See if I have any weird wire issues. Okay, now it's not doing it. If I plug it in, it's not doing it now. Let's see if it happens if I plug it in. It does it. If I turn it off, oh. Okay, it's working now. What the hell? What kind of bullshit? Okay, all right, it's working. It's working. I really want to know why it did that. Oh. Shit. All right. All right, so it did have an issue. There is a little bit of a crimp on one of the wires. It's probably getting crushed up against something. And if there's no ground that's being sent, then it's obviously not going to work out. Signals are going to be all messed up. It's just going to shoot the 5-volt, because I think ground is usually what controls it. Like, it sends signals through the ground. That's how it worked in 3D printers. Like, you would need to always attach the ground to whatever part of the board, and maybe like 5-volt to directly into a 5-volt power supply. I'm trying to find tape. Would be one. Just a quick fix. I just want to do quick fix. I just want to roast. So please forgive me. I am going to use white electrical tape after I unplug this. But yes, there is a big old nasty squish crimp. Not crimp, but squish, a squish that happens. So triple double check that the wire is not being crimped up somewhere. Or not crimped up, squished up against something. I apparently did a shitty job. put it back. That looks good. No crimping. I keep saying crimping. No squishing. I'm gonna go ahead. I'm gonna unplug this first of all. I'm just gonna go ahead. I'll put the USB in here. Find the hole. All right, that looks in line. Oh my God, what am I doing? Good, now it's in there nice and tight. Let's put it all back together. Making sure all the wires aren't being crimped up, messed up. See, saying crimp, keeps getting squashed up. Good. All right. Before I plug everything, let's just make sure that the variable motor is working. So this is the ESP Nano, ESP32, not the regular Arduino Nano, but the ESP32 Nano. So once I get this working on here with Artisan, then I'm also going to put the code for High Beam together. So you can either use Artisan or High Beam. Good, initialized. Fan's not going off automatically. Let's plug it in. Okay. All right. I gotta remember to put in there certain code that when it starts up again, it doesn't automatically turn the drum on. That doesn't really matter because you can always turn the drum off. And it does the exact same thing that the V2 does. It just turns the drum on automatically. So it's not a huge deal, but it's just something I want to add into the code. Anyways, so, all right, V1, same motor as the V2. Let's take a peek at it in here. So right now I have it set up. This is the basic, what's it called? The basic Skywalker setup. So, you know, when you're looking through, when you download the asset file off of GitHub, I just use the basic one. So I'll just click on, it's the basic ski top Artisan. I usually just click that, and you want to find your COM port. We have it set up to 3, but for us, for me, it's 10. For you, it might be something else. And it should kind of set up like this. Drum goes to straight to 100, whatever you do, every time. That's just how it's set up initially. So we'll turn it off. So that's drum to 0, drum on, drum 100%. And then we gotta double check if the exhaust fan works. Good, that wasn't working before because I was crimping the ground wire. Oh, God, I keep saying, I was squishing the ground wire. And what that does is, you can't control it, basically is what's going on. You need the ground wire to send the signals to control it. So that works. Let's check if the burner's working. Good, that's working just fine. Bean cooling goes on, that works. Box cooling on off, I don't care about that. I don't use the box cooling fan. So let's, so now with the new code that's all set up in, now we can control the drum motor speed. So we'll go to events. So right now, see, this is what happens when you turn on. Drum goes to automatically to 100. I'm gonna set this up to 0 to when we start. Actually, let's just do this. Let's just turn that off. Keep it off. Yeah, I'll keep the drum off. So as soon as I turn on, I want to make sure the drum is off. So drum 0 command is drum 0. All right. Next thing you want to go through is go to your sliders, go to drum, serial command. What's our serial command for drum? It's drum. Then whatever these are called. Okay. Right now the minimums are set to 0. So you can start off at 0. I don't recommend that. Probably if you have it too low, it won't have enough torque and it'll actually kill the motor because, you know, too many amps are being sent. It's having a hard time moving it. Because the driver of the motor is on the board, it's on the motor itself. So it will turn off if you go too slow. So I recommend, because you're never going to go lower than 50 minimum, then 100 maximum. And 100 max is without load 96 RPM. With load at max, like 500 gram, is probably around 77, maybe 70. I don't know. You can calculate it yourself, but okay. So that's on there. That's on there. All right. So now I should be able to just look here, click on that. By the way, there's 500 grams of beans in here, and it did it from a dead start, so that's pretty good. I'll jump it up to 100. Good. Turn on the air. That seems to be working fine. And then we'll turn on the burner. Never go to 100. We'll go to 95. That looks good. So what's the... Let me turn this drum off. We can slow it down. I'll turn this off because it's trying to heat up. All right. We're going to do some roasting soon. So you're probably asking yourself, what was the big deal? Why are we so focused on putting variable jump speed on here? Why can't we just keep it at 100 and do 60 RPM? You can. If you want to do whatever, I think the RPM for the V1 motor itself is like 70 or something, but a few things happen. When you're at that high RPM, the high RPMs that it's set up at that time, the beans actually have a really higher chance of burning on the flat side, or what is usually, I think it's called facing. We'll turn this down. So it does this thing called facing, which is usually a fancy word for, not even fancy, it's just your beans are getting burnt onto one side, on the flat side. It happens on different roasters different ways, but for our roaster, primarily it happens because we're flinging the beans over the lamp. So if I were to have a lamp, I think I have one in here. Ouch. I don't. Oh, there it is. So what is facing? That's occurring for us. So here's our little, this is an old one because this doesn't have the glass in it, but this is a V1 lamp. I think they just call it a covering. The top part is usually where the V is. The bottom part is basically where the rays come down, right? There, near infrared, far infrared light comes out. What happens is the beans get flung on top. The flat side of the bean stays in contact with this top surface, which is probably super hot right now, because the bulb itself are as such, where they are not shielded on one side, both sides are equally exposed. So what happens is that top part starts to absorb the infrared light, heats up, really hot. It's the closest to the bulb, so you know that side gets super hot. And what essentially happens is the bean will eventually fling over. So the bean will usually just fling over. And it'll usually kind of like, if you're lucky, the round part's here, because if you hit the round part, it usually just slides down pretty fast. Not many of the sides touch or hold and get stuck, but it definitely you'll have, if it's too fast, is you'll have it hit over, the flat side goes down. Maybe it's on here and it's trying to figure a way down left or right, but that's just enough time to burn that one side. So the whole point is, so why do we need the drum motor? Well, now you're slowing it down. So if you're dropping it down to say 50 RPMs, then the beans don't hit this. The beans actually will just kind of graze the top of it, and it'll just bounce right back down. A lot slower, still agitating. And I went from like 3 faced beans to 0 just by changing the RPM. That's one of the biggest advantages of it. The other one is you can argue adjusting temperature. So if you do change the speed of the drum, it does affect the temperature in ways. Especially if you go from like drum speed of 0 to like 100, you're gonna get a huge kind of change in your temperature. But it'll eventually kind of heat up and then stabilize. But you'll notice that as soon as you turn that drum on, the temperature has a big change. I think it usually increases if it's on 0 and then you preheat from like 200 and you turn on the drum, it might actually go up to 205 degrees Celsius. But anyways, that's one of the biggest reasons why a lot of us kind of want that. I mean, a lot of people do get upset like when they get those 3, sometimes 6 is the most I've ever had of those facing beans. And I feel like it's almost negated as soon as you put a variable drum motor in there. So now you're ranging RPMs for these roasts now are like maybe a 40 to 60 if you're slowing it down enough. Or RPMs, that is. Well, maybe 40 to 55 RPMs is about where the sweet spot is. Because the primary reason for the drum is to agitate, move the beans around. Shouldn't be a form of like transferring heat, not like a conduction roaster. But anyways, so yeah. So now that we have that RPM control, we don't have to worry about burning those face beans. Could slow it down to a crawl to 50% is really slow. Okay, so if you want to just bump it up, mess it around. All right, we're going to do a roast with this, okay? I'm going to turn this off. I'm going to turn this around. And this is all done through, it could also be done through Arduino at Mega just for Artisan, if you just want to use Artisan and save yourself a few bucks. But the eventual goal is to get ESP32 running on both Artisan and High Beam. Ultimate goal would be at the same time. Why? No reason why. More of just a cool feature thing. Okay. As so. Go back a little bit. Good. All right. Let's dump out these beans. Those have been my Captain Seasoning beans. Hard for the yawn. So that's all plugged in. Let's turn this back on. Let's turn this on. That's off. So I unplugged it. So let me turn this off. Plug this back in. All the fans and everything's gonna turn on. I'm gonna turn this on. Not sure why the drum fan automatically, or the air fan automatically turns on, but whatever. Anyways, so let's, is the drum working? So let's turn the drum on. There we go. Beans are cleared out, so let's go ahead, get this going, and let's warm this up. So, we'll turn the drum off, turn the fan on, and then we'll turn the heat on. Ooh. Oh, turn the music back on. Oh, I want you to look at the temperature when the drum's off, okay? So we'll pretend to start, just so we could track it. You could always turn it off, not so we don't have to track it. It's rising up pretty quick, so I'm gonna drop it down. So watch the temperature, right? We're just gonna turn the drum on. Okay, 3, 2, 1, drum on. See how it kind of spikes up real quick. Like a stubborn bean that's still stuck in there. There we go. Thank you. All right, I'm gonna leave the drum to about, I don't know. It's going to 207, so I'm gonna drop this down. Modulate it. I'm gonna open that up. Good. Let's do window capture too. I had problems with unscrewing the motor and bearing screw set. What do you mean? Like taking the motor out? And the bearing screw set. Oh. Like unscrewing the whole drum out? You had issues with the copper sleeve? I don't know. The copper holding thing? Or bronze? I don't know what it is. Whew. I'm gonna let that run. Right, I got some Kenya on the way I've been working on. I'm gonna try something new today. And what that means is I'm going to try to roast and turn just the drum off, or the heat off when I hit first crack, and just see how far momentum takes it, right? The thermal .193, that's good. Still warming up. Measured 350 grams. Oops, fuck. There we go. 350 grams. Oh, all right. It's a 186, so I'm going to raise this up to there. I'm like half asleep, so this is gonna be a really hard roast. All right. So once it hits 200 degrees, we're gonna add the beans in. Charge is on. I'm gonna lower the drum speed to about 80. We'll try 80. Well, let's go 75. So for this for today, just I'm gonna try something out. I'm really delving into the whole infrared radiation part of the roasting. So what does that entail? Yeah, why is this? I'm in Fahrenheit. I thought I was in Celsius. This is bad. I was wondering why everything was going so fast. Hold on. We're gonna dump these. We'll call these pre-warmed. I forget that we always set it up in Fahrenheit. My bad. Let's go ahead. Temperature, Celsius mode. We're gonna turn discard. Try to cool these off. We'll just say you got a quick warm up, right? Let's try this again. I'm gonna save these beans for another time. I'm gonna do another set. Okay. Oh, the burner's not even on. There it goes. Shoot, I thought thermal runaway was happening, considering how fast it was heating up. We're gonna try to go fast on this one. Let me see if I can find an A-log we could try out. No, because I don't have a roast to follow. I don't even have PID on this. Yeah, silly me thinking like, man, this thing preheats like a champion. Nope, I was wrong. Definitely was wrong. All right. So let's go elaborate on what we're gonna do for this roast. So this roast, I'm trying to really lay heavily into the radiant side of roasting. What does that mean? So the big thing about using, radiant roasting is that some say it's like a direct fire, and it penetrates, and all these kind of words are thrown around. But basically, we're gonna see kind of control the amount of absorption that takes place at the skin and of the bean, and really help shine the penetration part, right? So how deep can these far infrared light go into the bean, and can we have a roast that is developed if we turn off the burner right when first crack hits, right? So the coffee mine person from Germany, I think they're from Germany, was talking about wanting to try something where you have the radiant heat roaster, roast as fast as you kind of can, and then it goes up to first crack, and you just turn the lamp off, and you let that thermal inertia, I guess, just kind of guide that heat and through first crack, and then after that, maybe a minute 30 seconds when you start first crack, and then you end, and then you just drop the beans from there. Ooh, this is what I get for being up at 2 o'clock in the morning trying to roast. Okay, that's really high. Wasn't paying attention again. So I'll turn this part off too. The fan's not even on in the back, so I should drop the temperature up fast. So been a big question people always like to ask is preheat. What do I preheat to? Preheat to your charge temperature, and then preheat for 5 to 10 minutes. We'll say 10 minutes. Rubase says 5 minutes. We can do it for 10. So preheat for 10 minutes, and then once that happens, you should be ready to go. If it's your first time roasting, people tell you need to season your drum. No, you can't season this drum. For us, seasoning would be darkening it, because usually when you season it, you're trying to get the metals to a point where it could, for like maybe a solid drum roaster that's based on conduction, you're trying to set the metals up to where it can properly transfer that heat over, and that you need a few heat cycles and stuff of seasoning beans to get going with that. But for us, you need maybe a 10-minute cycle to warm up and burn out all of those oil coatings, right? But honestly, if it's your first roast, just do a seasoning roast. With that helps out a lot in terms of like what you're gonna expect on your first roast, how you're developing through each phase of the drying phase, and then you go into first crack or development phase. It kind of guides you on that path forward when you do that seasoning roast. Most of the time we fuck up, and you're probably just gonna throw away those beans, right? So there's nothing wrong with that. The new roaster, it's a lot different, and it's perfectly fine if you need to toss out a roast. Especially your first one. Your first one's never going to be the best. It's going to be the more memorable one because you remember how beans you had before just taste awful. Now you're roasting your own beans. All right, let's wait till this gets to 200. We'll drop the beans in, hit charge. Let me go ahead to start. All right, once it hits 200, we're gonna hit it pretty quick. All right, hits 200. I'm gonna drop this in. All right. Go. I usually wait close to the 4-minute mark, then I start dropping temps. I'm gonna start dropping temps a little bit slow this time around, okay? I'm really had that thermal no-shred going on right now. I check the beans, smell them. Smells good. Smells like grass, so I'm gonna wait. Just waiting till it gets yellow, okay? We're approaching the 4-minute mark. I might start changing the heat soon. Still going. See if it's in the dry phase still. Or if it's going in the dry phase. It is dry. Or dry end. So click that. We're hitting the 4-minute mark, so I'm going to start slowly going down. Okay. Comes first crack. There it is. So first crack started. I'm just gonna drop this sucker right there. I'm gonna go to 0. We're gonna go to first crack to about minute 30. And drop. Let's see how this goes. Can't wait to try these tomorrow. It's probably that fan. I probably should have moved it back a little bit. You're rubbing up against the front of the front of the back panel. Yep, that's what it is. All right. Well, I think that's it for tonight. I'll pull this back panel because that's annoying. Yeah, I'm totally making a new case for this. I ain't having that. All right. Anyways, if you have any questions, concerns, or want to see, if you want to see the code, I'll release it later sometime this week, okay? But anyways, if you watched this far, you were crazy.